Hi guys, good afternoon everyone. Good afternoon guys, how are you all? Okay, good afternoon everyone. Good afternoon Abhishek, good afternoon everyone. So the topic that we are going to study today is we'll be studying about a concept of orbital and its type, so that we can also learn about orbital configuration, because that's actually very important for us to know many of the concepts, right? Very good. So before starting with this topic, let me just quickly introduce myself to all the new learners here. So I am Manisha Rani, chemistry educator at Unacademy. I have enriched 5 years of experience at reputed institutes for more than 5 years. I have completed my masters from NIT Warangal and bachelor's from Delhi University. I have cracked IIT JAM and CSIR NET and GATE. I have given best ranks through my students in NEET as well as JEE Mains, and I am a plus verified tutor, guys. Very good. Now, talking about some information regarding the class, yes, let's just get to know about it. Good afternoon Veena, good afternoon Netik, how are you guys? Okay, thank you Abhishek. So talking about the Telegram channel, guys, if you will be joining it, you will be able to get all the information regarding the classes. So how you can join it, you can scan the code which is there on the screen, or what you can do, you can also use this link to join the Telegram channel, so that we can understand. Now let's just talk about some special type of classes which are there on our Unacademy app. So these special classes, they have a lot of benefits, and these are absolutely free the way we have the classes on YouTube. So these special classes, what you can do, what are the benefits for it? So first is you can learn from your favorite educators for free. You can engage with the educators via polls. You can clear your doubts in the live special classes, and there are so many, yes, benefits for it. So all of you, yes, you should join our special classes. So what is the special class timetable for the August? So the 3 upcoming classes which are absolutely free on our Unacademy app platform are: the first one is related to gas laws, which is on 3rd August. We'll be talking about all the gas laws like Boyle's law, Charles law, Avogadro law, right, Gay-Lussac's law. All those laws we'll be discussing, and we'll be talking about the some important type of numericals related to it. We'll discuss about kinetic theory of gases on 5th August, and 6th August we'll be discussing about numericals on states of matter. Now, what are the good things about Unacademy subscription? Yeah, today there is no class, Abhishek. Now talking about Unacademy subscription features, the first one, very important, is you can learn live from the comfort of your home. You don't have to step out anywhere, you don't have to waste the time. Now talking about next thing, you get unlimited access to all the courses. You will be learning from the top educators of India on a single platform, and yes, you will be having a regular doubt clearing sessions. There will be exhaustive coverage of syllabus done by us, and there will be a complete mentorship and guidance throughout. You will be getting all the study materials in the PDF format, and there will be practice tests assigned, live test series you will be getting, and there are different batch courses according to your requirement. Now Unacademy Plus subscription plans, they are at very affordable prices, guys. So for 24 months, like if you take for ISC class 11, guys, you will be getting for ISC class 12 subscription absolutely free. And yes, if you take for the 12 months, hardly the per class cost charges you like around 25 rupees, so it's very affordable, guys. Now let's just start with our topic without wasting the time. So what is orbital? First of all, let's just understand it, everyone. Yes, Veena, Netik, Abhishek, everyone, let's just understand what is orbital and how we can relate about it in a easiest manner. So orbital is nothing but, guys, it is a 3D space present in an orbit. What is orbital? It is a 3D space, three-dimensional space region, right, at which the probability of finding an electron is maximum, is called atomic orbital. And remember, it is present in orbit. So the 3D, yes, the 3D region at which The 3D region at which the probability of finding an electron, the probability of finding an electron is maximum. Finding an electron is maximum, at which the probability of finding an electron is maximum, is called atomic orbital. Yes, is called atomic orbital. Is called atomic orbital. Now where it is find out? Yes, like where you are able to see in an atom. So remember that it is present in orbit. It is present in orbit. Now one more thing you have to understand, guys, that orbit is the shell that where is electron revolve. Yes, absolutely correct, Abhishek. So orbit is nothing but it is the circular path in which, yes, electrons revolve around the nucleus. So it is present in orbit, which is also known as shell. It is also known as energy level, stationary level. So all these are the names for it. Now talking about it is present in orbit or shell and energy level. So how it is present and how we can understand about it, let's just see that. But before that, I wanted to give you a very important information, that remember, an orbital can accommodate maximum 2 electrons, guys. An orbital can accommodate maximum 2 electrons. That is a very important thing, because many times we get mistaken with the subshell as an orbital only. So many of the students, like suppose if anyone will ask you how many electrons are there in P orbital, yes, so P orbital, if they ask you, remember that it has to be 2 electrons only. But when they ask you P subshell, then it will be 6 electron. We'll discuss about it. So an orbital can accommodate maximum 2 electrons. Now how many orbitals are there? Let's just discuss about it, and we can understand more in detail that, yes, like how they are placed in an atom and some of the extra information. So an orbital can accommodate maximum 2 electrons, guys. And what are the types of orbital? Let's just discuss that first, and then we can understand many of the things in a better manner. Okay, now what are the types of orbital? There are 4 types of orbital which are seen till now. What are those orbital, guys? First one is S orbital, then you have P orbital, then you have D orbital, and there is one more which is F orbital. So there are 4 type of orbitals which are, yes, which are seen and which are discovered till now. S orbital, guys, remember S orbital, it is spherical in shape. SPDF, very good. S orbital is spherical in shape, while P orbital it is dumbbell shape, while D orbital it is double dumbbell shape. D orbital it is double dumbbell shape, and F orbital shape is complex. So we haven't given any specific name to it, but yeah, D orbital shape is complex. Now talking about S orbital, we understood it's spherical in shape, P orbital dumbbell, D orbital double dumbbell, and F orbital is complex. Now one more thing is very important for us to know, that S orbital always exists in one orientation only, because for spherical shape you cannot make a different orientation along the axis. So spherical S orbital, whenever it will be present in any shell, because obviously you can relate that this orbital will be present in an orbit, right? In a shell, orbitals are present in orbit. So whenever they will be present in an orbit, for spherical there is only one orientation, right? So there is only one orientation in orbit. So because of that, it can accommodate maximum 2 electrons only. But for P orbital, guys, there are 3 orientations found whenever, yes, whenever you will be seeing an P orbital in any orbit, in any shell. Yes, So there will be three orientations of p orbital, like how you can relate. So p orbital, what we have understood everyone, that this is dumbbell shape. Very good, Netik. So p orbital is dumbbell shape. Now this dumbbell shape can be along y-axis, can be along x-axis, because you should know that what is orbital. Orbital is a 3D region. So if it's a 3D region, so it's a three-dimensional region. All the three axes are present over there. So p orbital can be along with y-axis, can be along with x-axis, and can be along with the z-axis. So whenever p orbital will be present in any shell, it will be always present with along all the three, yes, along all the three axes, and these are the three orientation, first, second and third. Now remember, I told you that every orbital can maximum accommodate 2 electrons. Now what we can relate here, this one dumbbell py is one orbital, so it can accommodate here, it can accommodate 2 electron and again 2 electrons. So all together, yes, all together, when p orbital will be present in a shell, so what you can relate is that, guys, yes, you can relate very simple. It can accommodate maximum 6 electron, because each orientation can accommodate maximum 2 electrons. And yes, so overall p orbital as in whenever they'll be present in an atom, they'll be present in 3 orientation. Let me give you little brief idea, and then we'll discuss about more in detail. So guys, what is orbital? Let's just understand. Before that, I'll ask you one question. If someone will ask you that where you stay, okay, so what you will say? I stay in India, right? But in India, in the whole India, you are not staying, right? In whole India, you doesn't say. So if they'll ask you, suppose where you stay in India, say you stay in Delhi, right? So in Delhi, where you stay, obviously you are not staying in whole India, right? You are staying in, say, specific place, Delhi. You'll be staying somewhere, right? Okay, so yeah, like say Abhishek said Haryana, so we can relate with that also. So India, say in India you are staying in Haryana. Now in Haryana, say specifically you are staying in any of the place which we can relate. Say you are staying in Rohtak, okay, say in Haryana you are staying in Rohtak. Now in Rohtak also, guys, you won't be staying in the complete Rohtak, no. So if anyone has to say locate Abhishek, so I'm giving you an arbitrary situation. Say you are in India, then in your Haryana, say in Haryana you are in Rohtak. Now in Rohtak, you will be staying at some particular place, right? So what you can relate is very simple. We can talk about the address of that, like suppose you stay in some street number, house number, and like that, and then we can locate any of the particular person, correct? Suppose if I want to locate Netik, Abhishek, Veena, anyone, so what I should know, that which country is that person is, then in that which state, what place, and then what is the exact area, so I can locate it. Same way, guys, if you have to locate an electron, yes, if you want to locate an electron, how you will locate? So electron is present in an atom, okay, electron is present in an atom, but it is not present in the whole atom, yes. Now in that atom, where it is present in orbit. Orbit is a circular path in which electrons revolve around, right? So it's a circular path. Now but your electrons are not present in whole orbit. Where they are present? They are present in a orbital, okay, they are present in a orbital. So orbital, where they are present exactly, so we can relate. Therefore, like either S, P, D, F. So that's what we can relate, because in Rohtak we can talk about where street number, say house number, right? Then we should also understand like landmarks. So all those information we require, like that, if the electron is present, where it is present in the orbitals, it is going to present. Now here we understand one of the thing. It means you will not be having a structure of atom that we used to learn, that you will be having a spheres and all. So you'll be having a nucleus. Now you suppose you have a first shell. So in first shell there is found to be one orbital, right? So what you can relate is very simple. In an atom there is an orbit which is also called as shell. Now in the shell you can call it as, there is a present orbital, and along with the orbital, when you name the shell, you call it as subshell. So subshell you will be calling it as what? It's a part of shell which we call it as orbit. So basically that we can understand, yes, is going to have the electrons present in it, and that's how we can locate. So in P orbital, there are 3 orientations which are found along y-axis, x-axis and z-axis. So all the dumbbells can accommodate, every dumbbell can accommodate maximum 2 electrons, 2 to 4 and 2 6. Total P subshell, what we should say, P subshell, 3 orientations in orbit. So what we can relate, it means P subshell can accommodate maximum 6 electrons. Now talking about d orbital, guys. Yes, so what you should know, d orbital has how many orientations? So d orbital has 5 orientation. Whenever d orbital is present in an orbit, how it is present? It is present along with 5 orientation. It is never found to be existed in a single orientation. It is present with all the 5 orientations. What are those? So D is double dumbbell, right? So double dumbbell is, first we can find out that as non-axial, like along x-axis, y-axis, like that you can relate. So dxy you can talk about. It can be found in dyz also, because it can be found in between y and z axis also. If it can be found between x and y, it can found in between y and z also, correct. It can be found between x and z also. Clear with it, guys? Now let's just discuss what are the 5 orientations which we can discuss. So the first orientation is very simple. Along xy axis, along y z axis we can relate. It can be along x and z axis, so double dumbbell can exist. Now the another one is along the x axis and y axis. And the last but not the least, we'll discuss about it, but how we can name these orbitals. So dxy I can name it. I can name it as dyz. I can name it as dxz. And here I can name it as dx square minus y square. Why dx square minus y square, guys? Because yes, this is present along the axis. So this is say x and y. So along the axis it is present. So I'll be naming it as dx square y square, correct, so that we can relate. Now you can found one axis totally along the z axis, so this is called as dz square. So d orbital has 5 orientations which are found, and these 5 orientations are which and all? Along xy axis, yz axis, xz axis, x square minus y square and dz square. So this is easy. Okay, now every orientation is denoting an orbital. So every orientation can accommodate how many electrons, guys? Maximum 2. So 2 to 4, 6, 8 and 10. So maximum electrons a d subshell can have, yes, is how much, guys? Tell me. D subshell will be able to have how many maximum electrons? Tell me. Netik, Abhishek, everyone. Yes, so there will be 10 electrons. So there are 5 orientations. So they can accommodate maximum how many? 10 electrons in D subshell. Yes, in D subshell there can be maximum 10 electrons. And F orbital has 7 orientation, guys. Remember, it has 7 orientation, but we don't have to learn about all of their orientations and all. And every orientation can accommodate 2 electrons. So maximum it can accommodate how many? It can accommodate 14 electrons. So from here, what we have understood, we can make one conclusion here, that your s orbital in an atom can accommodate maximum s orbital, not s orbital, we should say s subshell, right? So s subshell, because any orbital can accommodate maximum 2 electrons only. This question is many times asked in NEET exam. So s subshell can accommodate 2 electrons maximum. P subshell can accommodate how many maximum, guys? 6 electrons. D subshell can accommodate maximum 10 electrons, and F subshell can accommodate maximum 14 electrons. So this is easy for us to relate. Okay, now sometimes what happens, guys, there is a difference, like sometimes it is asked regarding that what is the difference between orbit and orbital. So define it. So let's just quickly enlist some of the differences between orbit and orbital. So we'll get even more we'll get more clarity about that how orbital is different related to, yes, orbit. Okay, now orbit is what, guys? Orbit is a well-defined circular path in which electrons revolve around the nucleus, but according to Bohr model of an atom. So Bohr model of an atom gave us this concept. So how we can write it? We can write it very simple, that it is, yes, it is a well defined circular path. It is a well defined circular path, yes, around the nucleus, in which electrons revolve, around the nucleus in which electrons revolve, according to what? This was given according to Bohr. So nucleus in which electrons revolve, and according to what? According to Bohr's model. Yes, according to Bohr's model of an atom. But if I talk about orbital, what it is? It is a 3D space. The definition only I can write. What is that? It is a 3D space. Very good. So it is a 3D space around the nucleus in which, yes, it's a 3D space around the nucleus in which the probability of finding electron is maximum. Now, how we can relate the probability of finding an electron is maximum, and why you are telling that probability only? Yes, why you say probability only? Like, let me give you one example, very simple. Say there is a table in front of you. Okay, there is a, say, wooden table, and what I have done, I have come over there and down to that table I have put the iron chips. Yes, I have just placed it. Now you cannot see, like, you cannot go down to the table and see that where the chips are there. So you have to find out another way by which you have to locate where that iron chips are there. So what you will do? Yes, you will get one magnet, and what you will do? That magnet you will be moving here and there. Now when you will be moving that magnet here and there, what you can understand, you will say, where I am feeling the maximum attraction, there only probability is that more iron chips are there. Yes or no? But you cannot tell with the surety unless you are not seeing it clearly. Because if suppose I have placed the iron chips all over, so you will be getting attraction everywhere, like less attraction, like you will be getting everywhere. But where I have kept more of the iron chips, there you will get more of the attraction, right? So basically probability means the things, because in an atom we cannot see exactly the position because it's moving also. So we can just only tell where the probability of finding electron is maximum is called as orbital. Like suppose if you are feeling more attraction, right? So magnet will attract all in specific region, that's true. But what I have done, I'm not directly doing that. So on the table above you are, yes, you are rotating it so that you will get to know where, like, so that you will get to know where you're facing maximum attraction. Okay, so it's not a direct, like, that's why I kept on the table, like there is a table and down to it I have put the chips. So when you'll be moving above, you will get to know, okay, there I'm feeling maximum attraction, so here there is more iron chips which I can feel. So the same way you can tell, okay, according to me here there is a more probability of finding these iron chips, correct? Like that you can say. So same way in an orbital is nothing but it's a 3D region where the probability of finding electron is maximum, and it is in the accordance of, yes, it is in the accordance of quantum mechanical model of an atom. It is in the accordance of quantum mechanical model of an atom. Correct, guys? Very good. Now remember, maximum number of electrons in an orbit. You remember in Bohr model it was given to us how we can find it out by a formula 2n square. Yes, remember? So maximum number of electron in an orbit. Yeah, maximum number of electrons in an orbit yes, is equal to 2n square. But remember, your maximum number of electrons occupied by orbital is just 2. So we don't have to worry, we don't have to calculate. So maximum number of electrons occupied by orbital is 2. Okay, very good. Now orbit, they are only circular, so orbits are circular only. So orbits are circular, they doesn't have different shapes, but orbitals found to be in different shape. Yes, so what we can relate, it's very simple, it contains different shape, like S is spherical, P is dumbbell, T is double dumbbell, and like that. So it contains different shapes. Very good. Now remember, your orbits, they are non-directional. Why they are non-directional? Because it's circular. So circular, for circular region we can't say specific direction. So orbits are, yes, orbits are non-directional because they are spherical, they are circular. Orbits are non-directional because they are spherical. Now in orbital, S orbital is there, no, which is spherical. So remember that what we can understand, even in the orbital all are directional except S orbital. So except S orbital, all other orbits are directional. All other orbits are, orbitals are directional. Why? If you have a dumbbell, so you have a particular direction, no, like along the x-axis, y-axis, z-axis. But for spherical, you can't tell where it is exactly, so there it is non-directional. Clear with it, guys? Yes? Everyone? Yeah. So orbitals have different shapes, that is dumbbell, double dumbbell, and so on. Now I can tell you few things about the orbitals, and by which we'll be able to easily relate. So orbital concept we understood, it's a 3D space where the probability of finding electron is maximum. Now what you have to know, guys, for the orbital configuration, you should know, like in an atom. So atom is like a building, guys, in which, say, on first floor there is only one flat, on second floor there are 2 flats, third floor there are 3 flats, fourth floor there are 4 flats, like that. So it's very simple, guys. First floor, like first floor refers to here the first shell in an atom. So first shell in an atom, yes, has only one subshell, which is 1s. Second shell in an atom, yes, it has 2 subshells. So in an atom, if I talk about shells, and then we can also talk about subshells. So in an atom shell, we have, say, 1, 2, 3, 4, which we can also call it as K element shell, and then we have also subshells. Now talking about the shell, guys. So shell, we have, say, 1, 2, 3, 4. Now in the first shell, there is only one subshell. So I told you again, you can remember. So atom is like a building in which on first floor there is 1 flat, second floor there are 2 flats, third floor there are 3 flats, fourth floor there are 4 flats. So in the first shell there is only one subshell, which is 1s. In the second shell there is 2 subshells, 2s and 2p. And in the third shell there are, yes, in the third shell there are 3 subshells, 3s, 3p and 3d. While the fourth subshell, fourth shell has 4 subshells, 4s, 4p, 4d and 4f. So this is there. Okay. Now here we have to understand one more thing. What is that? Yes, if we have a range like this, like in the first shell there is 1s, second shell there is 2s, 2p, third shell there is 3s, 3p, 3d, fourth shell 4s, 4p, 4d, 5f. So what do you think now? Atom, what is the shape for it? So let's just understand that. So now all the concept that we used to learn in the lower classes is going to get vanished, because what we'll understand in an atom, say there is a first shell, there is a second shell, there is third shell, say. Let's just draw it together and make a messy structure of an atom, because actually it is like this only. So talking about the third shell, let's just understand. So how it is there, guys, exactly the structure, let's just understand. So in the first shell, guys, let's just relate. In the first shell there is, yes, in the first shell there is one subshell which we can relate, which is 1s. In the first shell only there is 1s. In the second shell, what you have, there is a 2s, but along with that 2s you have also 2p. Yes, so in the second shell only there will be a 2s, along with that there will be a 2p, which will be present along with 3 orientations, correct? In the third shell, if you will relate, yes, in the third shell How it is in the third shell, there are, yes, 3s like a circular shape. There is 3p, means 3 dumbbells. So I'm making a rangoli, right? 3p. And then there are 3d, means 5 double dumbbell also are there. So what you can relate, there are 5 double dumbbell. Yes, 5 double dumbbell. Like that there will be 5 double dumbbell. There is only one I have made, but there will be 5. Hi Rockstar, good afternoon. So actually this is the actual structure of atom, guys. By looking at it, you will be like, oh, what is this messy thing? If we have to make like this type of structure, we won't understand what is going on. It's like some like some kid has made a drawing, right? It looks like that, but it is actually an actual structure of atom. This is how, yes, this is how you have a orbitals which are placed. So this is only say 1 d orbital. Like that there are 5 d orbitals also present in an atom. So basically, guys, yes, the atom structure which we make, in which we make like, okay, there are shells in which we place the electrons, that we make it in order to not, yes, have the chaos in the structure. Because if we'll be making a structure like this, so this is an easy representation by which we can just interpret it. But this we cannot make the structure in order to represent anything, because this is going to be very complicated. But yeah, we have understood in first shell there is one subshell which is 1s. In second shell there is 2 subshells, 2s and 2p. In third shell there is 3s, 3p, 3d. In fourth shell there is 4s, 4p, 4d, 4f. Now let's just clear one thing off here, guys. You remember the first shell can have maximum how many electrons? Tell me, guys. First shell have maximum how many electrons, which we used to even call it as K shell? Yes, tell me. First shell or K shell, how many electrons it can have? Maximum 2, no? So where that 2 electrons are present? In the s orbital. In the second shell, which we also call it as L shell, can accommodate maximum 8 electrons, no? Now how these 8 electrons are? Yes, distributed. 2 electrons are present in 2s and 6 electrons are present in 2p. So altogether it becomes 8. Very good. Third shell, how many maximum it can accommodate according to 2n square? 2n square we can find it out. Now, so in first shell 2 into 1 square, 2 only. Yes, we got 2. But how these 2 are present in an atom? In the S subshell. In the second shell, there are 8 electrons which we can relate. So 2 into 2 square, it is 8. So this is L shell. This is K shell. So how these 8 electrons are placed? 2 electrons are present in S subshell and 6 electrons are present in P subshell. So total 8. In the third shell, maximum we can find out 2 into 3 square, 18 electrons it can have. But these 18 electrons, how they are distributed, guys? So 2 are present in S, 6 are present in P and 10 are present in D, which we have learned. Because S can have maximum 2, P subshell can have maximum 6 and D subshell can have maximum 10. So total it becomes 18. So this is how 18 electrons are distributed. And for fourth shell you can find it out. 2 into 4 square is equal to 32. Because 16 into 2. So how these 32 electrons are distributed? 2, 6, 10 and 14. So total you can relate 18 plus 14, you have 32. That is the total number of electrons. Clear with it, guys? So total number of electrons that we can have is very simple. Yeah, we can have how they are distributed, we can understand in the form of orbitals. Correct. Now let's just understand the orbital electronic configuration today, and then we'll be learning about, yes, we'll be learning about rest of the things that we'll be doing, that is quantum numbers will be doing in the next session, which is again a very important topic. Now how these atomic orbitals or subshells, they are distributed in an atom. Let's just get it cleared even in a little more detail. So you know that in the first shell there is only 1s, in second shell there is 2s, 2p. So you know that the first shell is the nearest to the nucleus. So the one which is nearest to the nucleus will have the least energy. After that, second shell is there. So second shell will have more energy. So if I arrange them in the increasing order of energy, so how I can arrange them, guys? Yes, I can arrange them 1s, 2s, 2p. Then after that 3s, 3p. Correct. So because first, second, third, first is having the least energy, then second shell is having the energy more than first shell, then third is having more than the second shell. So 3 is 3p. But what happens, guys, when we place the 3d, so because of the very big size of 3d, what happens, they go little beyond. Very good. Now what happens, because of the big size of 3d orbital, what you can relate is that it goes even beyond the 4s subshell. So 4s subshell, it goes little beyond, and because of this reason, guys, your 4s subshell has a lesser energy than 3d. Although yes guys, your 4s belongs to fourth shell, but because we are talking about increasing order of energy, so 3d subshell, because of d shell, or d, what we can say, orbital, which is d orbital, which is what, which is bulky and bigger in size. What happens, it goes beyond the 4s subshell, and if it goes beyond the 4s subshell, it goes beyond the 4s subshell, so you can relate 3d has a lesser energy than 4s. Now this exact idea will be also getting by a rule. So this is, we can relate with the help of n plus l rule, which we'll be learning with the help of quantum numbers in the next class. Okay, so what we can understand, that how we can arrange the orbitals in the presence on the basis of increasing order of energy. So this is the order, guys, which is 1s, 2s, 2p, 3s, and then you have 3p, 4s, 3d. Now I wanted to ask one question to all of you. Yes, tell me, we used to learn in the lower classes that the first shell can have 2, second can have 8, third can have 18 electrons. But whenever we have to write the configuration for potassium and calcium, what we used to write, tell me, what is the configuration of potassium and calcium? Everyone tell me. The K element shell configuration only. The K element shell configuration, everyone tell me what is there for potassium and calcium. Everyone. Yes? Good, Abhishek. Rest of the people, Netik, Rockstar, Veena, everyone. And for calcium, it is 2882. Yes, guys. So for potassium, we used to write 2881. Yeah. And for calcium, we used to write 2882. Very good. I hope everyone is clear. But if I'll ask you, yes, what you have to know, that we learned this, that K can have maximum 2, L can have 8, M can have 18, and N can have 32, right? That is there. So that we also used to learn. But what happens, like when we are in lower classes, teacher used to say, this is an exception for potassium and calcium. You learn it, instead of 289, it is 2881, or for calcium it is 2882. Like that. Yes, in many of the schools they teach, they say that potassium and calcium, it is little exception. And what you can relate, the outermost shell cannot have more than 8 electron, and that's why we are shifting 1 electron to the next shell. Yeah. So why we write the configuration of potassium as 2881 and calcium as 2882? We'll get that answer just within 2 minutes. We'll be getting that why it is. Yes. So let's just discuss that. So basically, the correct reason will learn. So suppose you have to write the configuration for hydrogen. How you will write? Hydrogen, you will write the configuration, electronic configuration, orbital electronic configuration. Yes, if you have to write orbital electronic configuration, how you will write it? Yes, you will write it very simple. You will write it as 1s1. Yeah, you will write it as 1s1. For helium, you will write it as 1s2, because now remember, K element shell is an old concept and it won't be able to give you all of the answers regarding the different properties. Who can give you all the answers regarding properties, guys? Very simple, your orbital configuration. So how you can write the orbital configuration? It's again very simple. You can just remember that suppose you are standing here, right? You are standing here and you are playing a game. So someone will come and give you what? Someone will come and give you balls, or say small like balls or small sticks. Someone is coming and giving you, and how many sticks they are going to give you, you have to put them in these boxes. Now the first box can have maximum 2, second box also can have maximum 2, third box can have maximum 6, fourth can have again 2, fifth can have 6, sixth can have 2, eighth can have 10, like that you have. So depending upon how many sticks or balls are given to you, that only you will be able to fill. So if someone is giving you 2 sticks, so you will fill in the first box only, so you will fill 1 as 2. Someone is giving you 8 sticks, so you will do 2 in here, 2 in here, and then remaining 4 in the third one. Like that you will be filling. So basically what you have to know, the sticks are nothing but the electrons. Now who is someone? The atom. So depending upon the number of atom, like the atomic number of atom, you can fill the, yes, you can fill the electrons. For the hydrogen it is going to be 1s1. For helium it is going to be, yes, it is going to be 1s2. For lithium it is going to be what configuration, guys? 1s2, 2s1, because once the 1s is completely filled, that is filled with 2 electrons, I cannot fill more electron because it's that capacity, no? Like suppose if someone will ask you that you have a poly bag, right, which is say 500 gram. So let's not take an example of poly bag because poly bags are banned. Yes, how many of you guys know? You should not take plastic poly bags. It is banned. And now there is like at many of the states, they have imposed a fine of using, yes, the plastic poly bags, because plastic is very dangerous for our environment, guys. If you will be using plastic poly bags, they takes million of years to decompose, or they are not biodegradable, they are non-biodegradable. So they causes lot of pollution. You cannot burn them as well. If you'll burn them, they'll be releasing many toxic greenhouse gases, which is also a problem. Okay, so remember that. Suppose if you have so we are not using a poly bag, even for example, we are using something else. So we are using say you have a cloth bag, right, or say you have a paper bag. So there is a paper bag whose capacity is 500 grams. Yes, so how much you can put? You can put 500 grams only. No, in that 500 grams you cannot put 1 kg. No, tell me guys, can you put in the 500 grams paper bag 1 kg stuff? Can you put in that? No, because that's its capacity. Yes. So Abhishek, you should understand from here that S orbital 1s have the maximum capacity to put 2 electrons. So you cannot have 1s3. You can have maximum 1s2. Once it is filled, you will go to the another bag and then you will put the electrons. Correct? So 1s2, 2s1 will be for the lithium. What will be there for beryllium, guys? Beryllium atomic number is 4. So how I'll be writing the configuration? I'll be writing 1s2, 2s2 and then 2p. Yes. 2p, anything will come? No, I'm filled. No, I have only 4 electron. I told you, no, it's just a game. Someone comes you and gives you a ball that you have to put in different boxes. Correct. So if someone is giving you only 1 ball, so you will be able to put in 1 box only, which can have maximum 2. So like that, it's very easy. Okay, so beryllium 1s2, 2s2, like that. Suppose if I'm writing for carbon, so carbon, what it is going to be the configuration? Tell me guys. For carbon, atomic number is 6. So what I'll write? 1s2 filled, 2s2 filled, 4 are filled, and then after 2s 2p comes, so 2p2. You have only 2. See, p can have maximum 6. P can have maximum 6. This has a capacity to put 6 in it, but you have only 2 balls. No, you are left with only 2 balls, so you are going to put that only. So carbon will be 1s2, 2s2, 2p2. Correct guys? Yes. Very good. So like that, what you can do, you can put it for many of the, yes, you can put for many of the lessons, right? Like you can put for many of the, yes, what you can relate is that you can put for many of the elements, you can write the configuration in the same manner. So C6, like nitrogen, if I write 7, what will be the configuration? 1s2, 2s2, 2p3, right? So can you write for all the elements configuration like this way? Yes, everyone. Yes, you can write it. Now let me give you the answer of this question, everyone. Yes, I told you, in our school they used to make us fool in the lower classes that you learn for potassium and calcium like this only. You say potassium is 2881 and calcium is 2882. They used to say, that you learn like this only. The last shell cannot have more than 8. So that way only you put it. So that was actually a rule given by Bohr, but that was not correct, because we were getting the results like that, and that's why we just made a jugaad that okay, this can help us, right, to give the answer that moment, and you don't have to tell in detail. So detailed answer is due to the orbitals. Let's just check. So guys, potassium atomic number is 19, no? If you have to write its configuration, what I'll write, 1s2, 2s2, 2p6, 3s2, 3p, yes, how much it is? 3p6 and 4s1. Now let's just count how these electrons are getting distributed. Let's just count that. So in the first shell there is only one s subshell, so there is 2 electron. In second shell there are 2 subshells, 2s and 2p, so 2 plus 6, 8. So in the second shell there is 8 electrons. Third shell there are 2 subshells, 3s2 and 3p6. So how many electrons are there? That's why in third shell 8 electrons only, while the 1 electron which is left, it goes in the fourth shell, and that's why the configuration for potassium we write it as 2881, not 289. Got that, guys? In spite of having the capability of M shell which can have 18 electron, but still we doesn't keep 18, we keep 81, because when you check the actual configuration, the orbital electronic configuration, what we found, yes, the orbital electronic configuration, what we found, guys, tell me. We found that the 1 electron is not going in the third shell anymore, it's going in the fourth shell, and this is what we can understand. Everyone clear? Yes. So can you write it for calcium as well? Yes, for calcium atomic number is 20. So what will be the configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So again we can understand very simple. In the first shell there is 2 electrons only. In second shell there are 8 electrons. In third shell there is again 8 electrons. In the fourth shell there is 2 electrons. So that's why, guys, for calcium we used to write 2882 configuration. What we used to write? 2882. We used to write the configuration for calcium. Yes, I hope everyone understood for the first 20 elements how you can write down the electronic configuration. So if you will see the order that we have just seen right now, what is that? We have understood like 1s, 2s, 2p, 3s, 3p, 4s, 3d. So we have learned till here only, but by this you cannot write the configuration of all the 118 elements, no, because maximum which you can put over here is 2, 6, 2, 10. So you can put it up to 30th element, where you can do it up to 30th element only, you can do it. So if you can do it up to 30th element only, what we can understand here, guys? Yes, if we can do it up to 30th element only, what we can understand? It's very simple. Yes, we have to know the complete order, and how we can learn it, let's just see that. So there is one trick, guys. You can write 1s, 2s, 2p, then in third shell 3s, 3p, 3d, in fourth shell 4s, 4p, 4d, 4f. Then from fourth shell, every shell can have maximum 4 subshells only, 5p, 5d, 5f. Then you have 6s, 6p, 6d, 6f. Like that, 7s, 7p, because we have 7 periods only. So we have what you can relate, maximum that you'll be talking about is 7th shell. 7s, 7p, 7d, 7f, like that. Now if I have to tell the complete order of the 118 elements, how I can tell? There is a trick. So you have to go downwards, 1s, then you will get 2s, then obviously 2p, 3s, then 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, like that. This is a trick. 4f, 5d, 6p, 7s. Yes, Are you getting that? 5f, 6d, 7p, 6f, 7d, and like that you can relate. So by this way you can get to know the whole 118 elements. What is the electronic configuration? You can get by this trick. Yes, you can get by this trick. How? You have to remember that in the first shell there is one subshell only, so that I mentioned. In second shell there is two subshells only, so that I mentioned. Third shell there are three subshells. Fourth shell there are four subshells, because we learned no atom is just like a building in which first floor there is only one flat, second floor there are two flats, third floor there are three flats, like that. Fourth floor there is four flats, but in this building after fourth floor every floor is having four flats only. So like fifth floor is also four, sixth is also four, seventh is also four, and so on. So maximum subshells which you can have is 4. And how you can learn that? The whole configuration, first 1s, then 2s, 2p, 3s, 3p, 4s, and like that we can write it off. So if you want, we can write it quickly. What is that? It's 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Yes, because what you can relate? 3p, 4s, 3d, then 4p, 5s, 4p, 5s, 4d. We can relate that. 4p, 5s, 4d. Correct. Then what will have? 5p, 6s, 5d. Like that you can understand, and you can keep on writing the configurations depending upon what is the requirement. So understood everyone? So this is how you can write the configuration of any of the elements, and that is what we can relate. So if I'll ask you that, suppose you have to write the configuration for phosphorus, all of you can write it. Write the configuration for phosphorus. For the scandium, phosphorus atomic number is 15, scandium is 21. Vanadium, yes, 23. So all of you should write these configuration. Yeah, everyone should write it for phosphorus, scandium, and vanadium. Phosphorus atomic number is 15, scandium is 21, vanadium is 23. Yes, for phosphorus, scandium, and vanadium. Phosphorus atomic number is 15. So what configuration I can write? 1s2, 2s2, 2p6, 3s2, and 3p. How much? Because 6 for 10, 12, 3p3. Scandium, it is going to be what? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d1, because you can count it off. 6 for 10, 12, 18, 20, 21. I have to fill it. So accordingly, I'll fill vanadium. It will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. But now here 3d3 it is going to be. So like that we can write the basic configuration. Now when we'll be meeting in the next session, what we'll be doing, guys, we'll be learning about quantum numbers, and then we'll be talking about many of the things in detail, because quantum numbers, they are very important. They are a set of numbers which helps us to find out, yes, the information regarding the orbital and electrons. So that quantum numbers, for sure, if you're targeting any competitive exam, remember that, guys, that quantum numbers is one topic from where you can expect question for 100%. It's a very, very important topic which we'll be discussing in the next class. So make sure next class also everyone is joining, and we'll be learning about quantum numbers in the really, really easiest manner, so that you'll be able to do any question coming from quantum numbers in easiest way. Very good. Very good, Abhishek, Netik, Veena, Rockstar, everyone. So this is what we are going to do in the next class. So we discussed today basics about what we discussed. What is orbit, what is orbital, what are the different four types of orbital, which is which is SPDF. Then when these orbitals they are present in an orbit, they have a specific orientation. So depending upon that, in a shell, when an orbit is present, we call it as subshell, and a particular subshell can have a particular number of electrons. Like S subshell can have 2, P subshell can have 6, D subshell can have 10, and D subshell can have 14 electrons. And then we arrange these orbitals in the form of like increasing order of energy, and when we did that, we have got this order. Now how we get this order, will be also proving this with the help of one rule, which is N plus L rule. But before learning that rule, guys, what we'll be doing, we'll be learning about quantum numbers in the next session, which is going to be really interesting session. Okay, so I have summarized also what and all things we have discussed. Now let me just quickly give some information regarding our classes, guys. Let's just discuss that. So talking about what are the upcoming batches for class 11 and class 12, guys. So for class 11, we have an upcoming batch which is starting from day after tomorrow, which is on 4th August. Who is taking the chemistry classes over there? I am taking the chemistry classes, which is every Tuesday, Thursday, Saturday, 4 to 5 p.m. And biology is taken by Lakshya Gera sir, physics is taken by Mohana Dharam ma'am, and maths is taken by Rahul Mohanani sir. So we all the teachers will be taking the classes for you guys, and we'll be doing the exhaustive coverage of syllabus. Now talking about Achievers batch. Achievers batch, what you have to know, it is for class 12. But before telling about class 12, guys, so if you're a class 11 student, for sure you should take the subscription, because if you'll be taking the subscription for ISC class 11, you'll be getting the subscription for ISC class 12 absolutely free. You'll be getting it absolutely free, so make sure you are doing that. And now if I talk about another thing for ISC class 12, again all the teachers are same. We will make sure that we are doing the exhaustive coverage of syllabus along with the previous year questions and all the types of doubt clearing things. Thank you, Abhishek. Thank you so much. Now talking about again, like for the class 12, we have all the same teachers and will be taking your classes regularly. So in class 12, I take the classes Monday, Wednesday, Friday, 4 to 5 p.m. Now let me introduce you to our community, which is there on our Unacademy app. So this community is very important, guys, because here we all will be connected throughout 24/7. And how we'll be connected. So first thing, you will never miss any update from your favorite educator. You'll be getting all the information over there. You'll be getting the session notes and practice material. You can share your feedback directly with the educators via polls in the community. Now talking about a few more things regarding the session, guys, that today we don't have a special class on the Unacademy platform, but the special classes, I wanted to tell all of you again the schedule of our special classes. And what is that? So we'll be having, for the states of matter, we'll be having the special classes. 3rd August we'll be discussing gas laws. 5th August we'll be discussing kinetic theory of gases, and 6th August we'll be learning about numericals on states of matter. So make sure you are joining these special classes even on our Unacademy platform as well. Okay guys, we'll be meeting in the next session then. Thank you all of you. Bye bye. Make sure you are subscribing our channel. You are pressing the bell icon so that you will be getting notification regarding all of our classes. So thank you everyone. Bye bye. Bye guys. Thank you.